Good morning all to all. So we have already completed sets up to universal set and the intervals as a subset of real numbers. Intervals as a subset of real numbers, and also discussed the power set, universal set, subset, intervals as a subset of real numbers. Next we discussed a power set, later discussed a universal set. Now we are going to discuss set operations. So you know the algebraic operators. What are that? Addition, subtraction, multiplication and division. Similarly, we also have a set operations which you can apply between the two sets. These set operations can apply between the two sets. But what are those set operations? Set operations. Set operations. What are those set operations? First see. One is the union, another one is the intersection, third one is difference, and the fourth one is complement. These are the set operations: union, intersection, difference and complement. Union is gives adding the elements of sets, adding elements of the sets. Intersection is common elements of the sets, common element of the sets. Difference is a deleting of elements, deleting of the elements. The complement is element not in that set. These are the meaning of the set operation. Union means you are going to add the elements of those sets. Intersection means we are going to take commonality of the set, common elements of the sets. Difference means we are to delete the elements from the set. And complement is element not present in that set. Now what is union of the sets? Union of two sets. A comma B are two sets. A comma B are two sets, and their union is A union B. This is the set operation which is defined as like this sum. A union B is the set. A set and B also set, their union also what? Set. So this set has elements. What are those elements? X. But what is that X? That X may be present in A or may be present in B, or that X is belongs to A, or X belongs to B, or X belongs to what? A and B. A union B is the set which has the elements. But what are those elements? Those elements may be present in A, or those elements may be present in B, or those elements may be present in both A and B or not. So the example, if we see here, A is the set having the elements A, B, C, D, E, and B is the set having the elements A, E, I, O, U. Then what is A union B? You add the elements of A and elements of B. But take the consideration here is, in the set, repetition of the elements are not allowed. In sets, repetition of elements are not allowed. So that's why A is repeated twice, but we have to take only one time. B, C, D, but E is repeated how many times? 2 times. But we have to consider only one time. We have to consider only one time. Why? While writing the elements in a set form, repetition of the elements are not allowed. Same element should not write. If you have a same element is repeated thrice, but you have to write only one time. Since if you want to write a element, if you want to write the elements in roster form, means listing of the elements. Roster form means you have to list the elements. If you want to write the elements in a roster form, repetition of the elements are not allowed. So that's why I have written only one time. Now if you see this set, what are its nature? You take any element in this set, it may be present in A, or it may be present in B, or it may be present in A and B or not. If I take A, it is present in A and B. If I take a C, it is present in only A. If I take a O, it is present only in B. So that's why A union B is consisting of elements of A or elements of B, or maybe both. Next, intersection of two sets. Intersection of two sets. A comma B are two sets. Their intersection is denoted by their intersection is A intersection B, which is defined as, look at here, A intersection B means what is the nature of intersection? We want to take the common elements of the set, sets. So A intersection B, when A comma B are, if A comma B are two sets, their intersection is also a set or not? But it consisting the elements X. But what is the nature of X? That X may be present in A and that X must be present in B or not. What is A intersection B? A intersection B is gives that the element present in A and element present in B or not. That is the intersection. Example. Next, see example. A is the set 1, 2, 3, 4, 5 and B is the set 2, 4, 6, 8. Then A intersection B is gives what? Commonality of these two sets or not. So first you list out the common elements of two sets. That is a 2 and 4. These are the common elements of two sets. That you write here. Next, A intersection means commonality of common elements of both the sets. Next, disjoint sets. Intersection B means you take a commonality of the common elements of both sets. But disjoint sets are mutually exclusive. mutually exclusive. Two sets are two sets A comma B. Two sets A comma B are disjoint. Now, what is the meaning? The meaning itself you see, disjoint. Joint means commonality. Disjoint means what? No common or that. Joint means common. Disjoint means no common. So that's why two sets A comma B are a disjoint if their intersection is equal to null set or not. Two sets A comma B are a disjoint if their intersection is what? Null set. So the example you see here, A is the set 1, 3, 5, 7 and B is the set 2, 4, 6, 8. What is A intersection B? Common elements of A and B. There is no common element. That's why it is a 5. So that A comma B are what? A comma B are disjoint. Disjoint. Next, difference of the sets. Difference of the sets. A comma B are two sets. A comma B are what? Two sets. Their difference is A minus B. A comma B are two sets. Their difference is what? A minus B. Which is defined as like this. You write A minus B. So what is the meaning of A minus B? What is the meaning of A minus B? A minus B meaning is from set A, you delete the elements of B. A minus B meaning is what? From set A, you delete the elements of a B. After that, whatever the elements are left in A, which are gives A minus B. A minus B means from set A you delete elements of B. After deleted elements of B, the rest of elements gives A minus B. So that's why how you write this sum? X is such that after deleting the elements of B, what happened? The elements are present in A and the elements not in B are not. A minus B means A minus B is consisting of the elements or not. But what are those elements? Those elements are in A, but those elements are not in B. Why they are not in B? Since from A you deleted the elements of B or not. From A you deleted the elements of B. That's why A minus B gives in A minus B present only the elements of A but not elements of B. So that is the meaning of A minus B. For example, see here, A is 1, 2, 3, 4, 5. B is what? 2, 4, 6, 8, 10. So what is A minus B? A minus B gives what? For A minus B, from A you delete elements of B. What are the elements of B here? 2 and 4. You delete it. After that, whatever the elements are left, you write. What are those elements left? 1, 3, 5. So this is your A minus B. From A we are deleting the elements of B. Whatever the elements of B present in A, those elements of B you delete it. After that you write down the rest of elements, which gives A minus B. In A minus B you take any element. What is its nature? That element is present only in A but not in B. That's why this A minus B sometimes can also be written as what? A and B complement or not. A minus B sometimes also written as what? A and B complement. So what does it mean? Which are the elements of A and not elements of B or not? X not belongs to B means B complementum. X not belongs to B. So A minus B sometimes is also written as what? A intersection B complement. That means it is the element is present in A but not in BM. Okay, note down. We'll give 3 minutes time. Okay. Next, see the complement of the set. Complement of the set. Next, complement of the set. Complement of the set. Next, complement of the set. What is the complement of the set? A is the set. Complement A is the set. Complement of the set. Complement of the set. denoted by, complement of the set is denoted by what? A complement, or like this one. A is the set, complement of the set denoted by what? A complement or A power, you just write a C, that gives what? It represents a complement. But what is the complementum? A complement or A complement is gives what? This is the set consisting of the A complement means what? A is the set, the complement of the A is denoted by what? A dash, which is defined as A complement is consisting the elements of A. So A complement is what? A complement is consists the elements X, but those X are what? Those X are not belongs to A. So that means what? It can also be written as it is consisting of a X, but this A complement is also written as what? From universal set you delete A. A complement means what? From universal set you delete A. So what does it mean? In A complement we have the elements are present in U and the element is not present in A. A complement means what? It is the element is a part of a universal set, but not A. Complement means not A. What you have to understand here, A complement is you understand as not A. Not A means what? The elements not present in A. But where it present? It present in universal set, but not in A. So A complement can also be written as what? A complement can also be written as what? Universal set minus A. That is why its definition is what? X belongs to U and X is not belongs to A or not. X belongs to U and X is not belongs to A. This is the definition of A complement. Now the example you see here, not example, example you see here, universal set is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, correct. But A set is what? 2, 3, 5, 7. But A complement means what? From universal set you delete the elements of A or not. A complement is gives what? From universal set you have to delete the elements of A. So what are the elements of A here? 2, 3, 5 and 7 or not. What are those elements? 1, 4, 6, 8 and 9. These are the A complement. So these elements are what? These are present in a universal set but not present in set A. So that is the meaning of this. What are the properties here? The properties of universal set. Number 1, A complement whole complement is always A. Number 2, A and A complement, A complement intersection is what? Always phi. Why? A complement means not the elements of A. This is elements of A. This is not elements of A. Then their commonality is what? Obviously null set or null. So A union A complement. This is gives elements of A and this is gives not elements of A. Then their union is obviously gives what? Universal set or not. Their intersection is a null set, but their A and A complement intersection is a null set, but their union is what? Universal set. Now, so some properties of union and intersection. Here you see the properties. So commutative property, commutative. Next is associative, commutative property, associative property, distributive property, distributive property, commutative, associative, distributive property, De Morgan laws, De Morgan laws, involutory property, involutory properties, involutory property, involutory properties. Next, identity, identity rule, identity property. What is the commutative property? A union B is equal to B union A. That means union satisfies commutative property. Intersection also satisfies which property? Commutative property. Associative property means A union B union C is equal to what? A union B union CM. Associative property is what? This one. So what is that associative property? How many sets are here? Here we have a 3 sets. So in 3 sets, if we take in order A, B, C, B has a choice of associate with A or C. But in all the cases, result is the same. So here what happened? In this case, B is associate with C, but in this case, B is associate with A. But in both the cases, the result is the same. Same it is hold for this one. A intersection B intersection C is equal to A intersection B intersection C. There is the associative property. Next, distributive property. Distributive law. What is the distributive law? Here, and distribute union or distribute addition or not. What is the distributive property here? And distributing which one? Union. Or union distribute which one? And or not. So that's why these are called as a distributive property. What we are getting here? A and B. Next, what is their operation? Union. Next, again A and C. Here also what? Union distributes and. Here and distributes union. But here union distributes and. So first A union B. Next, what is their operator in between? And A union C. So this is called as what? It is the distributive law. Next is a De Morgan law. De Morgan law. Is the De Morgan law. It is an important one. De Morgan law. De Morgan law is the important one. What is the De Morgan law? A union B whole complement is equal to, take complement individually, A complement. Union complement is what? Intersection B complement. Take a complement. A complement. Union complement is intersection B complement. Next, A intersection B whole complement is gives what? A complement. Intersection complement is what? Union and B complement. This is the De Morgan law. Next, adimpotent law. Adimpotent law. What is adimpotent law? See, A intersection A, the intersection of a same set is gives a same set or not. A intersection A, intersection of a same set say, is gives a same set. Next, similarly, union of a same set is also gives what? Same set or not. Intersection of a same set is gives a same set, and the union of a same set is gives what? Same set. Next one is the identity law. Identity law. What is this identity law? You must get a same set. So that means what? A intersection universal set is what? A. If A is the set, take a intersection with universal set, then only we are getting A or not. Identity means you get a same set. Under intersection, when you get a same set, if you take a intersection with universal set or not. If take a intersection with universal set, then you get a same set or not. Under union, what happened when you get a same set? A union phi is equal to what? A or not. Under intersection, we get a same set if we take an intersection with universal set. Under union, you get a same set if you take a union with null set or not. So that's why these are called as which laws? Identity laws. So this is the properties. Next, Venn diagrams and application to set theory. Wait 2-3 minutes. Okay, Amma. So now we just see the Venn diagrams. Venn diagrams. What are Venn diagrams? Using a representation of a set. Venn diagrams are Venn diagrams. What are the Venn diagrams? Venn diagrams are pictorial representation of a set. Pictorial representation of a set. Representation of the set. Now, what is a Venn diagram? Venn diagrams are what? Venn diagrams are pictorial representation of the sets. But what is that pictorial representation? Rectangle is gives universal set. Rectangle is gives universal set. Circle is gives set. Circle is gives what? Representation of set. But a dot is gives element of the set. Element of the set. And this is the universal set is represented by rectangle. Circle is represented by set is denoted by circle. Dot is denoted by the universal set is denoted by rectangle. Set is denoted by circle. Element of the set is denoted by dot. Now, so if I write A union B, how you represent this set? See, this is the set, this is set A, and this is what? Set A, and this is set B. A union B, but the rectangle is gives what? Universal sets. Sets in that universal sets are denoted by which one? Circles. Now A union B means it is a joining of A and B. So A union B means what? We are going to join the elements of A and B. So that's why this total part is gives what? A union B or not. This is A union B. But what is A intersection B? A representation of A intersection B. See here, this is A, this is universal set A, this is A, this is B. Here what happened? Both circles are intersected or not? Both circles are intersected means they have a commonality. So what is that commonality? This is the commonality, intersection of these two. So this is the common part of a both circles. That common part of a both circles is represent what? A intersection BM. Next you see A minus B. Next you see A minus B. What is A minus B? I have already told you that what is the representation of A minus B? Which are the elements of A but not elements of B or not? Which are the elements of A but not elements of B? That is represent A minus B. So this is the set, and this is also a set. This is set A and set B. What is A minus B? Elements of A but not elements of B. Means only this part or not. Elements of A but not elements of B is used only this part. And next we see A complement. Next we see A complement. This is the universal set. This is the set A. A complement means what? Other than set A. A complement is other than set A. So that is gives this part or not. Other than A is gives A complement. But this is what? universal set. Now you just go for some symmetrical difference. Symmetric difference of two sets. Symmetrical difference of a two sets. A comma B are two sets. A comma B are two sets. Their symmetric difference, their symmetric difference, their symmetric difference is denoted by, their symmetric difference is denoted by, their symmetric difference is denoted by what? A delta B. This, what is this A delta B? A delta B is consisting of the elements x. What is the nature of that x? That x is belongs to A minus B, or that x is belongs to what? B minus A. Now, what is the meaning of a symmetric difference? Symmetric difference of A is denoted by which one? A delta B. Symmetric difference of a two sets denoted by what? A delta B. But what is that A delta B? A delta B has a elements. But what are those elements? Those elements may be present in A minus B, or present in which one? B minus A. So that means what? A delta B simply gives what? A minus B union B minus A or not. Sometimes it can also be written as what? From A union B, you delete A intersection B, then automatically we can get a symmetric difference of a two sets. A symmetric difference is depending on union of these two sets or not. Symmetric differences depend on union of these two sets. But union satisfies which property? Commutative property. Union satisfies which property? Commutative property. That's why A delta B also satisfies which property? Commutative property. So what is that? A delta B is always equal to what? B delta A. But how you remember A delta B in another formatum? So A delta B means A minus B. A minus B means what? Only the elements of A but not B. What is B minus A meaning is what? Only the elements of B but not A. So what it represents? It represents that which consisting of elements of A or elements of B but not both elements of A and B. That's why A delta B is also written as what? A union B minus what? A intersection B or not. But how you represent A delta B in Venn diagrams? See, this is set A. This is universal set. So A delta B is represent what? You take A union B. Now this is represent A and B. What is A delta B? This part or not? A delta B is what? From A union B, how I got A delta BM? From A union B, I deleted which one? A intersection B. This part is gives what? A intersection B. From A union B, I deleted which one? A intersection B. Then automatically I got what? A delta B. So what does it mean? So this part is gives what? Elements of A but not B or not. This part is gives elements of A but not B. But this part is gives what? Elements of B but not A. Elements of B but not A. So in A intersection B complement can also be written as what? A minus B. B intersection A complement can also be written as what? B minus A. This one. The next you see A intersection B whole complement. How you represent in Venn diagram? This is the universal set. This is A and this is B. A intersection B whole complement means what? From A intersection B whole complement can also be written as what? From universal set you delete A intersection B or not. Why? What is the meaning of a complementum? Delete that set from universal set or not. The meaning of complement is deleting of a set from universal set. So this is the whole rectangle is your universal set or not. From that you delete A intersection B, means only this part. Then the remaining part is give this one or not. Next, A union B whole complement. How you write A union B whole complement? Is what? From universal set you delete A union B. This is A union B. From universal set, this is the whole universal set or not? This is universal set. From this universal set you delete this A union B part. Then what is left? From the universal set I deleted A union B. Then I got what? This one or not? This is universal set. From that I deleted A. Now these are the Venn diagrams and their representations, symmetric differences. Now the application of a set, just see the, again I will tell you, see the Venn diagrams are pictorial representation of the sets. So how you are going to represent them? Universal set always represented by rectangle, any set is represented by a circle, and elements of the set is represented by dot. A union B means what? Adding of a set A and set B. That's why this total is shaded or not. A intersection B means what? Commonality of a two sets. That's why I shaded only common part of A and B. A minus B means what? It is a part of A but not B. So this is a B part but not B means only this part I have to shade it on. A complement means what? Not A complement is gives what? But this is A complement. A complement means other than set A. So this is set A. Other than set A is gives this shaded part. This total shaded part. Next I discuss the symmetric difference of a two sets. What is the symmetric difference of a two sets denoted by what? A delta B. But actually what is the symmetric difference of two sets? In a symmetric difference of a two sets, we have the elements of A minus B or B minus A. So what does it mean? They have the elements of A or elements of B, but not both elements. They have elements of A or elements of B, but not have the common elements of A and B. Not have common elements of A and B. So that's why from A union B I deleted A intersection B. As you are aware of it, union satisfies a commutative property. That's why the difference also satisfies a which property? Symmetric difference also commutative property. But how I draw this Venn diagram? From this you see From A union B, you want to delete A intersection B part. This is A union B, from which I deleted A intersection B. Next, A intersection B whole complement. What is the meaning of a complementum? Delete that set from universal set. So from universal set, I deleted A intersection B. This is the universal set. In that, just I deleted which one? A intersection B. So A union B whole complement. This is also gives what? From universal set you delete A union B. So this whole is gives a which set? Universal setum. From that I deleted A union B. This is the part. So now tomorrow we'll do the problems. After that, applications of sets. Note down, then leave the class. First note down, then leave the class.